Dear students, in today's class, we will solve numerical problem 2.9, which is on page number 54. Let me read the statement first. When brakes are applied, the speed of a train decreases from 96 km per hour to 48 km per hour in 800 seconds, in 800 minutes. How much further will the train move before coming to rest, assuming the retardation to be constant? Okay, so now let us solve this numerical problem. The curriculum which we are following, that is Federal Board, Punjab Text Board, it's chapter number 2, Kinematics, problem 2.9, and in today's class we will solve two numerical problems, 2.9 as well as 2.10, because 2.10 is related to 2.9. First, we will write data. So, what is the given data in this question? When brakes are applied, the speed of the train decreases from 96 km per hour to 48 km per hour. So, actually, initial and final velocities are given. So, in given data, we will write initial speed or velocity of the train, which is denoted by Vi and is equals to 96 km per hour. Now, as we know that the standard unit of velocity is meter per second, but the initial speed is given in kilometer per hour. So first, we will try to convert this speed into meter per second. So for conversion, as we know that if we want to convert speed from kilometer per hour into meter per second, we will divide this value with 3.6, which is explained in our previous video. So here I will write meter per second. This is the simplest way for the conversion of kilometer per hour into meter per second. Divide this value just by 3.6, so you will get the speed in meter per second. By dividing these two, we get 96 divided by 3.6. The answer is, what is the answer? 96 divided by 3.6. Anyone please? 26.6. Very good. Meters per second. And we have final velocity of the train. So final velocity of the train, which is denoted by Vf and is equals to how much? 48 km per hour. We will convert 48 km per hour into meter per second. So just by dividing this value with 3.6, the answer will be in meter per second. By dividing these two, we get 13.33 meters per second. Okay. In 800 meters. So during this, what happened? The train covered 800 meters distance. So distance covered during Vf and Vi is equals to S is equals to 800 meters. Now the point to be noted, this is not the total distance covered by the train. This is the distance which is covered when the speed of the train decreased from 26.6 meter per second to 13.33 meter per second. Is it clear? So here I have mentioned distance covered during Vf and Vi, which is 800 meters. How much farther? Now, what we have to find in this numerical problem, what we have to find is how much farther will the train move before coming to rest? Distance covered by the train before coming to rest is equals to S, and S is equals to what? Now there is difference between this S and this S. This S is the distance covered by the train when its speed was decreasing from 26.6 meter per second to 13.33 meter per second. But now still the train is not at rest. The brakes are applied, and according to the given statement, we have to find the distance covered between this speed and rest. Means you have to calculate to find the distance before coming to rest. Is it clear? Okay. Now see here, we don't have acceleration, so with the help of these three given data, we will find the acceleration of the train first. We don't have acceleration. We will need, in order to find this distance, we will need acceleration. Why we will need acceleration? Because we know two equations of motion. One is s is equals to vit plus half at square. We can find distance with the help of this equation, and similarly we can find the distance with the help of this equation. These both are valid. But in order to find distance, you will need acceleration. Also in this equation, if you want to find distance, you will need acceleration. So first, we will find acceleration of the train, which is not given in the problem, with the help of these three. And then according to the statement, the retardation of the train is constant, means which is not changing. So let us calculate acceleration with the help of this. There are two methods. We don't have time, so we cannot apply the formula of acceleration, which is Vf minus Vi divided by t. Because for acceleration we will need time, so we don't have time. Then there is only one option of applying what? Third equation of motion. What is third equation of motion? 2as is equals to Vf square minus Vi square. We have distance, final velocity, initial velocity. So A will be equals to Vf square minus Vi square divided by 2s. By putting the values of Vf, Vi and s, we will get, what is the value of Vf? 13.33 meter per second whole square minus, what is the value of initial velocity? 26.6 meters per second whole square divided by 2 multiplied by distance. What is the distance covered? 800 meters. Okay, 13.33 whole square. 177.688. Okay, let me round off this value to 177.7. Okay, meter square per second square minus 26.6 whole square. 707.56 divided by 1600 meters. Now find out the difference. 177.7 minus
529.86.
minus 529.86. Okay, let me round off this value to 530 meters square per second square divided by 1600 meters. So meter and meter will be cancelled. By dividing these two,
0.33125
minus 0.33125. So this will be 3 meter per second square. There is no need to write more than 3 digits after decimal. Clear? Okay. So we got the acceleration. But according to the statement, acceleration is what? Acceleration is constant. The train is moving with constant retardation. Retardation is basically the negative acceleration. When the speed of the train is decreasing uniformly, then that acceleration is known as retardation. Okay. Now we can find this distance. But for this distance, be careful that, or for this distance, our initial speed will be 13.33 meter per second and our final speed will be 0. Final speed will be 0 meter per second. In order to find this distance, our initial speed will be 13.33 meter per second and our final speed will be 0 meter per second. Okay? When the speed was decreasing from this to this, the distance covered by the train was 800 meters. Now, according to this question, the question is that how much further the train will move before coming to rest. So, how much further means this will now become your initial speed and Vf is 0. Is it clear? Again, we will apply the same equation. We have acceleration, we can find. So by applying the same formula, that is 2as is equals to Vf square minus Vi square. The same equation will be applied here. S will be equals to Vf square minus Vi square divided by 2a. What is the final velocity? 0 meter per second minus initial velocity, that will be 13.33 meter per second whole square divided by 2 multiplied by acceleration. We already calculated acceleration, which is minus 0.331 meter per second square. This will become 13.33 square of 13.33. 7.7 meter square per second square divided by minus 0.662 meter per second square. This will be cancelled with this, and meter with square, minus with minus, and finally we get 177.7 divided by 0.662. 268.44 meters. So this will be the distance covered by the train before coming to rest. So I hope that you people got the concept of this numerical problem. Any question?